all, welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on advanced data types. So let's dive in. So why do we need advanced data types? Here, if you are a data scientist and you're working with Python, you already know that Python has some data types in it, like fundamental data types, container data types, like tuples, list, we have set, dictionaries. But as you keep on programming or keep on coding, you will come across complex problems to be solved, and you will find out these built-in data types, given data types, were not that sufficient enough or efficient enough to tackle those problems. So now the concept of advanced data types comes. Advanced data types will help your code to be faster, more efficient, and do the task more clean and better way. So we'll see that. So we'll start with how we can import these advanced data types to our Python code. So let's see that. So now this collections is the library that you're gonna use in order to import these data types into your Python code. So what is this collections now? So this Python has this open source community, and they have libraries, n number of libraries, where if at all you want to import a machine learning model, you have a library for that. For visualizations, you have matplotlib, scikit-learn. Just like that, you have a library for this advanced data types too. So this is a built-in library, so you don't have to install it externally using pip. Here you can just say from. So the library is collections, the module collections module. We can import. So the first advanced data type that you're gonna see is counter. So this is how you import the advanced data type from the library collections. So let's speak about this counter advanced data type. It is used for counting the number of frequencies that is occurring. So let's say you have a social media app and you are trying to find the number of occurrences of a particular word, and counter will help you to find the frequency. Maybe it's for spam detection, ham detection, or maybe your sentiment analysis basically. But now, why use counter? If you go with the traditional Python, you can even use dictionaries and you'll get it. So in dictionaries, you can store the word along with the count as its value. Word will be the key and count will be the value to the item. And if at all the word is you find the word again and again, you increment that count +1 +1, and you can keep going. It works totally fine. But why do we have counter for this? The reason is counter keeps it in the order of 1. So the time complexity, I've told you, there is order of 1, order of n. So here it's gonna be constant. The time taken to find these values or assign the values or something. Counter takes order of 1. It's gonna be constant always. So I'll show you how to use counter. So here I've already imported counter from the library collections, and yeah. I'm gonna write count. I'm gonna store the count of these values in the variables count, and I'm gonna say counter of, I'm passing in the number of values that I want to take count of. So I'm saying hello, and I'm gonna say world, then I'm gonna say hello there. Oh, it's gonna be in. Then I'm gonna say hello Python. Okay, quite a few terms here. Now if I print count, you notice that this has given me the number of times a particular frequency is occurring for it. Like hello has repeated 3 times, world 1 time. You can see the data that is being provided. It is providing in a form of dictionary. This is how it is working. So you can use this for further sentiment analysis if you want. So also notice that counter had a very few lines of code to be written. Unlike when you try in your traditional Python to write the same logic, you might end up writing a lot of lines of code, and it also won't be that memory efficient as compared to this counter, and as it uses order of 1 in time complexity, right? So when it comes to this counter, this advanced data type is used mainly in natural language processing and also in ranking systems, or let's say you want to find the number of frequencies of the log errors that you want. Counter does it very efficiently, and yeah, it can also be used in ranking systems too. So the next one that you're going to see is default dictionary, and in default dictionary, the advanced data type that you're going to see now, what it's going to do exactly is, so normally when you create a dictionary, you have this key and value. You search for the key and the value is there. But what if the key is not present? Then you want it to create a default value to it. That's how default dictionary works. So it creates a default key and gives the default value to it. So let's see how that is working. Notice that I have this particular list with tuple values in it, and each has the class section and the particular student in a particular class. So now I want to use this default dictionary. I want to show how powerful it is, how we can use it very efficiently. So here I'm saying default students, a variable, and I'm saying default dictionary. And default dictionary, in my default dictionary, I want the default data type to be as list. It should be in a list. Now here I can say student of, let's say, A, if at all default students, okay, not students of A. So default student of A. Notice that I have not assigned any key towards this particular variable. There's nothing, it is just an empty dictionary. Now if I run it, it gives me a empty list. By default there is an empty list. This is what default dictionary does. It doesn't throw an error. Unlike your normal dictionary, it doesn't throw an error. And if I want to assign a value, so anyway it has a list, I can say dot append, and I'm gonna append RIY, yeah. So this worked pretty fine. If I check the default DEFAU, yeah. Okay, you have the particular value that you wanted. You have the key, the item. So the key value item, that's what I meant. Now this, you don't have to do it manually. You can use a for loop too, and this is much more efficient because your default dictionary doesn't throw an error. That means if at all you have a particular class with no value towards it, it's not gonna throw an error. So here you can say for I, or let's say for CLS comma val in students. Okay, I'm just extracting the tuple from this particular list, subtuples from this particular list. And then what I'm going to do, if I print, I just want to show you what I'm doing. So PCLS comma val, you can see it's nothing but those values inside it. I'm just extracting it from using for loop, and I want to store them in my default dictionary. So default FAULT, default std of students of class. So class nothing but A, B, C, or there is only A and B here, dot append. And if I go with val is nothing but the names of the students, and if I run this, these values have been stored. And if I say print my default dictionary, I want to see what all values have been stored. Yeah, you can see how beautifully it has stored the particular class and assigned those students itself accordingly. Even for class B, you have the students accordingly. So this is how you can use default dictionary. Now you saw that how you can use default dictionaries to to particular algorithms or code that you're coding. And this application can be used mainly for grouping data, finding relationship between those keys, or maybe when the keys are unpredictable, you cannot predict what key comes next. That's where you can use this default dictionary. Just like counters, it is also having the order of 1. So if at all you want to update the value or change the value, it doesn't have a if else overhead logic behind it. It works very efficiently and fast. So yeah, that's one of the very important reason why we can use default dictionary. So that's all for this video. I hope you found this helpful. If it did, do subscribe and stay tuned for the next one. Thank you.